In this setup, we have a spring that's attached to a force sensor and a motion detector down here. And effectively what we're going to do is we're going to take this large mass, we're going to hang it from this spring, we're going to allow the spring to oscillate back and forth. And while it's oscillating back and forth, the force sensor is going to measure the force, while the motion detector measures the position. And then Logger Pro can use that position along with time to calculate the velocity at any given point, as well as the acceleration. So we're going to look at basically four things: the position as it relates to time, the velocity as it relates to time, the acceleration as it relates to time, and then the force as it relates to time as this is oscillating back and forth. All right, so we stop the motion, allow it to settle, and then we're going to go ahead and start collecting data. So let's begin this again. Then we collect our data, and you can see what happens to the velocity versus time, the position versus time, force, and acceleration versus time. The interesting thing about acceleration and force is those are actually mimic each other, and hopefully that makes sense. Newton's second law says net force equals mass times acceleration. So with the spring balancing gravity, really the only net force is the additional force added to the spring. So with the force of the additional force of the spring, then that essentially is going to tell us that that's going to be proportional to the acceleration. All right, so let's look at the data for this. All right, so next we're going to auto scale this, kind of stretch this out so we can see the entire motion for each one of these. And you can look at these, and they look like sine and cosine curves. So we're going to get a little bit more in depth into each one of these. The position versus time graph, we're going to go ahead and say that is going to be our cosine curve. So we're going to stretch this out to where we only have 3 cycles that are going to be measured. All right, so let's go ahead and focus on these. 1.86 seconds. And we're going to go over to 4.14 seconds. All right, do the same thing with the force versus time graph so that we can compare each time frame. Okay, so the things you should notice here: position versus time gives me a cosine curve. And with a position versus time being a cosine, this is 1 full cycle where it goes from, for this time frame right here. And that effectively, if you notice the amount of time given right here, that time, 0.7 seconds, 0.76 seconds, that's going to be the period. That's going to be the amount of time it takes to complete 1 cycle. Now, if you look at the velocity versus time graph, you'll notice the velocity versus time graph is actually a sine curve, but it's actually negative. So it's actually a negative sine curve. When we start talking about calculus, we know the velocity is going to be the derivative of the position versus time. And when you take a derivative of a cosine, you get negative sine. Now, the derivative of negative sine gives me negative cosine. You'll actually notice the acceleration, right? The acceleration right here matches the position versus time, except it's flipped. So the acceleration is actually the second derivative with respect to time of the position, which gives us a negative cosine curve. And of course, the force is going to be equal to mass times acceleration. So we can use this acceleration, we can use that force, and we can actually determine what the mass of the system is.